Ladies and gentlemen, welcome to this presentation. Okay, I'm the Wenben Tsai. Okay, I'm the speaker right now, and also my topic is the development of high-efficiency fans in Taiwan. And actually, this program, okay, we have partnership with the Intelligent Motor Motion Research Alliance in Taiwan. Okay. And this alliance basically includes about 30 companies in Taiwan. They are most small to medium companies, motor companies. We do the basic research related to the motor technology and the motion control technology. Okay? And also the second party is the Luchang Industrial Company in Taiwan. And Luchang is the expert in motor production, particularly in the motor winding technologies. Okay? And the third one is the Breeze Technologies in Malaysia. And Breeze will be responsible for our future, promotion in Malaysia for all the high-efficiency fans, products in Malaysia. Okay? Then I will start my presentation now. Okay. Let me begin with the story. Actually, Taiwan, maybe some of you, have heard, Taiwan was a kingdom of fan making. About back to 15 to 20 years ago, there are more than 1,000 fan makers in Taiwan. We produce more than 100 million of house fans in Taiwan. But due to the cost of labor and the land, goes high and high. Most of the fan makers in Taiwan moved to the southern China, Vietnam, Thailand, and so on. Okay, so maybe you will ask, what's the survival strategy for the fan maker still stay in Taiwan? That there are three approach I will share with you. Our survival strategy for present Taiwan fan makers, basically there are three points, okay, three strategies, three methods. From business point of view, we transform ourselves from the OEM, original equipment manufacturer, to the ODM, original design and own brand manufacturer. Because of this kind of transformation, we can add more value to our company, to our products. Okay, this is from the business point of view. And also, we would like to synergy with other, technology fields, okay, such as electronics. The reason is, in Taiwan, we almost produce half, maybe more than 50% of mobile phone and notebook PC, are produced by the Taiwanese, manufacturer. So we are very strong in electronics, okay? So we would like to have some kind of synergy with them, okay? If we use electronics, we can improve the user friendliness a lot, just like using the remote control with the fan products, or maybe we can add some sensor, something like a temperature sensor, then take the feedback and control the fan speed, okay? And actually, most importantly is, we would like to improve using this kind of technology, electronic technology. We can improve the most important feature for the fan, that is high air moving efficiency. Okay, I think air moving efficiency is the echo trend of the fan products. Not in the future, actually, right now. For example, in United States, if you want to get the energy efficiency labeling like Energy Star, you have to pass the minimal energy requirement. That is, for ceiling fan, as example, is 75 CFM per watt. Then you can get the Energy Star labeling. And I think this minimum requirement will go higher and higher. And I think the similar situation already occurs in Malaysia, probably in the southern Asia, like India. Okay, and this is our the three strategies we like to can make us to survive in the future fan market. And I would tell you about how to make the higher air moving efficiency. In Taiwan, now we take three approaches. Number one, we use computer-aided design based aerodynamic design of fan blade. CAE means computer-aided engineering. It means it's kind of software. You can simulate the airflow passing through the fan blade. Then you can change the shape of the fan blade and make the fan blade, very efficient to carry on the airflow field. Okay, this is I will make some example, in the next page. Okay, the second is we use high efficiency BPM. BPM means brushless PM motor to replace the single phase induction motor. Maybe more than 90% of fan motor right now is using the single phase AC motor. And their efficiency is just around from 30% to 40%, okay? But if you use high efficiency brushless PM motor, the efficiency motor itself can go high from 80% to 90%. There's a big difference between these two motor technologies, okay? Then we intend to use this new motor technology to replace the conventional one, okay? The third one is, unfortunately, if you want to use the brushless PM motor, you need more complicated electronic control, okay? That is adjustable speed control, okay? To replace the SPC. SPC is kind of split phase capacitor run or start, the technology. This one is basically, SPC is, is suitable for the single phase, induction motor. Okay, but for the brushless PM motor, we have to use adjustable speed control. They are, another advantage when you use adjustable speed control. Because if you use this kind of control, you can control the speed at very, low speed. Okay, because most of the time when you use a fan, actually you don't want, the high speed all the time. Sometimes you just want to circulate in the air. Then you can control the fan at very low speed. That will save a lot of energy. Okay, for ceiling fan as example, usually if you use the lowest speed, it only takes about 1 watt to 2 watt. Yeah, that is very, very energy efficient. Okay, then I will show you some examples for these three technology approach. The number one is, this is a standard design for the actual fan, ventilating fan. You can see there's a 9 blades here, and it's a straight shape. The blade shape is straight. Okay, after we use a 3D computer fluid dynamics, analysis, that's a kind of a computer, use computer to assist, to analyze the airflow field. Then we can modify the fan blade shape as a curve type. And also we choose 7 blades. This kind of blade modification will make the whole system become much more efficient, maybe more than 30% to 40%. Yeah. So this is kind of technology we are using now to design the fan blade. The second one, I'll describe about the difference between the BPM and also single phase induction motor. I also take ceiling fan as an example. Like this one is a 5 blade, 6 inches ceiling fan, okay? Running at 200 RPM, okay? If you look at the conventional AC motor, diameter is around 188 millimeter. Compared with a brushless PM motor, it's only 150. Okay, less than 150. So we can, by comparison, we can reduce energy consumption. For instance, like for single phase AC, it's about 110 watt. But if you use brushless PM, only 45 watt, is 60% less. Okay, this is for energy consumption. For the weight, original conventional AC motor is around 10 kilogram. But if we use the brushless PM motor, only 6 kilogram. It's a 40% material reduce. Okay, and these two parameters will save the much more energy, from the energy consumption, also from the weight reduction. Okay, this is for motor. Then the next one I will describe about the control. Using the adjustable speed control. Okay, this is here block diagram, for our controller. This is trademarked as a vector drive. Okay, it's very complicated. I won't go to the detail. Okay, but there's 2 points worth noting. First one, you see, our controller only, connected with the motor, 3-phase brushless PM motor through the phase winding. There's no sensor feedback. No sensor feedback. For other techniques, usually they have to take some sensor to detect the magnetic field inside the motor. But for our technology, we don't need any sensor to combine with the motor. Because if you use sensor to combine with the motor, the sensor itself is not reliable, just like the copper and the steel, inside the motor. So our technology, we don't need any sensor. So it's a sensorless operation, sensorless technology. Okay, this is the first point. The second point is our vector drive can generate almost, pure sinusoidal motor current. And this motor current, because it's sinusoidal, so it will ensure high efficiency and silent operation. Because right now, the consumer usually not only concerned about the energy consumption, they also concerned about the noise, particularly during the night. If you have very high pitch noise, then the consumer won't accept that. Okay, so our technology will assume the high efficiency, but also the silent operation. You won't hear any high pitch noise at all. Okay, this is our technology. We trademark as a vector drive. Okay, then I will show you some products we already developed using the technology I described. Basically, 2 categories. One is a pedestal fan, as this. I think I won't stick. This is a pedestal fan. The energy consumption is around 20 watt to 30 watt. Okay, but for the conventional one, usually it's around maybe 65 up to the 85 for pedestal fan. Okay, for ceiling fan, usually it's around 30 watt. Using new technology, we have 30 watt to 50 watt. Depends on the fan blade, the length of fan blade. But for conventional one, usually it takes about 85 to 100. Okay, so you can see using this technology, we have more than 50% energy reduction. Okay, this is our new technology. Okay, and I will show you. We also have another, products, which is combined with a solar panel, okay? Because solar panel generate the low voltage, direct current, and using our technology, you can just simply put the 12 volt or 24 volt, solar panel voltage into our controller, then you can, operate it. And this solar power require about 25 watt only. 25 watt only, okay? So this is the shape is just like your conventional, ceiling fan, shape. Okay. Finally, I will describe what's the eco benefits for our technology. Okay. When you put in the products, I will take ceiling fan as example. If there's two situations. One is if the ceiling fan operating alone, you can see because the energy consumption is reduced about 60%, about 2/3. So the greenhouse gas can be reduced about, from 100% to about 34%. That's it. So there are 2/3 of reduction for the greenhouse gas. Then the other one is the weight reduction. It's about 1/2. You can reduce, 50% around, for the weight reduction. Okay. This is for ceiling fan itself. But the ceiling fan has another effect is they can operating with the air conditioner, okay, just like this one. Because when you operate a ceiling fan, that will produce some kind of, we call the wind chill effect. Wind chill effect. If you have the wind chill effect, then normally you can raise up your temperature setting for air conditioner by maybe 2 to 3 degrees. That will save a lot of electric bill. Okay, so this is two eco benefits. Okay, this is just take ceiling fan as example. Of course, you can have different kinds of fan, to combine with the air conditioner. Then you have the similar effect. Okay. Okay, so thank you for your attention.